happens means in the universe, however it's set up, A has to happen. And once you go down that path of A, then you must go down the path that says B, right? But what is the number that goes here? This is the probability of B happening given that A has happened. Okay? So we put probability of A, and this is probability of B given A, right? Okay, and all of these letters are interchangeable with other things. So if you wanted A complement in B or B complement in A or whatever it might be, you just switch around the letters and follow down the appropriate paths. Okay. There's a special case. And that is if events A and B are independent, okay? I was having a lot of fun out there. A and B are independent. Okay? Independent is not mutually exclusive, right? We throw these words around and they get confused sometimes. Independent means that the outcomes of one event has nothing to do with the outcomes of the other event. Okay? So what happens in event B has nothing to do with event A. Alright? So in the case of the flight delays and the snowstorm, those were not independent because the probability of a delay depended on whether or not there was a snowstorm. But when we talked about the two coin flips, those two coin flips are independent. What happens on the second coin flip does not depend at all on what happened during the first coin flip. Okay? Or when we were picking out those fruit flies, we said that it was so big that even if I picked out a gray fruit fly the first time, it had no impact on whether or not I'm going to pick a gray or black fruit fly the second time. Okay? So the probability of the second event had nothing to do with the probability of the outcome of the first event. Okay? That's what A and B are independent. It means the outcome of one event is not influenced at all by the outcome of the other event. Okay? And so what that means is that if A and B are independent, I'm going to run out of space on this board. Then the probability of B given A is just equal to what?
Probability of B.
The probability of B. Okay? The probability of B given A, because even if we know that A has happened, it has no impact on whether or not B happens. Okay? So the probability of B happening is just the probability of B happening. Okay? So I could say, what's the probability that this coin flip is going to land heads? And you say, you're going to say 0.5. I'm going to say, wait a second. The previous coin flip, it landed tails. So does your answer change? No. Okay? So even if I given that the previous coin flip was heads or tails, what's the probability that this one's going to be heads or tails? It doesn't, it's the same. Okay? So if we plug that in here, probability of A and B is equal to the probability of A times the probability of B, okay? If A and B are independent. independent, can they be mutually exclusive? Yes, no, maybe, maybe, impossible. If A and B are independent, can they also be mutually exclusive?
Yes.
Now the answer is no. The answer is no, okay? If A and B are independent, they cannot be mutually exclusive, okay? Why? What did it mean for A and B to be, if A and B are mutually exclusive, are mutually exclusive, then what is the probability of A and B equals 0, right? This is not equal to the probability of A times the probability of B, okay? Alright, these two are not equal, right? So this is one way to check for independence, right? If this A and B are independent, then this is going to hold true, alright? If A and B are independent, they're not. It's not going to equal 0 unless one of those events has a 0 probability, okay? And then it becomes trivial to ask the probability of A and B. It's like, what's the probability that the coin lands heads, and the probability that yes means no? It just doesn't make sense.
So does that mean that if A and B are independent, then they cannot be mutually exclusive?
That is true. That
And
is
vice
correct.
versa.
And vice versa, yeah.
Okay.
If they're mutually exclusive, they cannot be independent. And if they are independent, they cannot be mutually exclusive. Exactly. Yeah, so, because mutually exclusive, right? So, two events that are mutually exclusive is I draw a card that is a heart, and I draw a card that is a spade, right? Those two events, if I draw a single card, I cannot have at the same time draw a heart and a spade, okay? So those are mutually exclusive. So, independent would say, what's the probability that I draw a spade? The answer is 0.25, okay? Or 1 out of 4. But if I tell you, well, oh, look at my card is a heart, and then I ask you, what's the probability that this card is also a spade? Your answer is not going to be 1 out of 4, it's going to be 0, okay? So your probability of B given A changes now that I've told you. The probability that it's a spade, given that it's a heart, has now changed. It's no longer just the probability that it's a spade. Okay. Alright, let's take a quick break, like maybe 10 minutes, and we'll